Hello, my friends. We are going to solve these equations. And what we notice about them, even though they're fractions and we've been doing this type of thing before, now the denominators, and sometimes the numerator, but in this case the denominator, can be factored. So the first thing we notice is that x squared minus 6x can actually be factored. So before we do anything else, we're gonna rewrite the problem. So we're gonna say 6 over, and the greatest common factor of x squared minus 6x is x. We'll pull x, and then we'll say x minus 6. That's the factored form of that quadratic. Equals x minus 6 over x minus, and if you want, you can put 1 over 1, or you can just put 1. It doesn't matter. At this point, you should make a list over here of x cannot be. And x cannot be 0 or 6. And the reason x cannot be 0 or 6 is because if we look at this denominator, if we were to take x and set it equal to 0, or if we were to take x minus 6 and set it equal to 0, then those are the numbers that if we put it in the problem would be undefined. So we're going to say x can't be 0 or 6. So if we do all the algebra correctly, and we get one, or perhaps both of those numbers, then neither of them can be a solution, even though algebraically they work just fine. Okay, so now we're going to get a common denominator, or at least common multiple, my apologies. And the least common multiple is going to be x minus 6. And so the first fraction needs nothing. This next fraction, he needs an x minus 6. And the last one needs everything. And so if the last one needs everything, then we're going to write it as x squared minus 6x. And that will take care of this, and this. So we multiplied the entire problem by x minus 6. When we do that, we get 6 equals. When we do this portion, right here, x minus 6 times x minus 6, that's going to get us x squared minus 12x plus 36. And then here we need to be particularly careful as well. This negative sign right here, that negative sign is going to impact the x squared and impact the negative 6. So that's going to give us negative x squared and positive 6x. So then we go ahead and we combine like terms. Well, if we combine like terms, let's see. We have an x squared here, and the opposite of x squared here, so those will cancel each other out. And then we have 6 equals negative 12x and positive 6x are going to give me negative 6x. And then I have plus 36. And then I'm going to move the 36 over, which is going to give me negative 30 equals negative 6x. So x equals 5. Yes. And then let's check it. Let's just check it and see if it works. So that would be 6 over 5 squared minus 6 times 5 would equal 5 minus 6 over 5 minus 1. So that would be 6 over 25 minus 30 equals negative 1/5 minus 1. That would be 6 over negative 5 equals negative 1/5 minus 5/5. And that would be 6 over negative 5 equals negative 6 over 5, which is the same thing. So it does check, so my answer is correct. My answer is also not one of these numbers, so my answer is good. So my answer is 5. Okay, let's try the next one. First thing I want to notice is that this could be rewritten. Maybe I should write it this way. Maybe I should say that x squared minus 7x is the same thing as x minus 7. Everybody agree? Okay, so we have x minus 85 over x minus 7 plus 12 over x minus 7 equals x plus 7 over x. So first of all, we are going to state that x cannot be 0 or 7, because those would be the numbers that would make the denominator equal to 0. If I solved this problem, I would say x equals 0, x minus 7 equals 0, so x equals 7. So that's how we get these two numbers. Okay. I want all the denominators to be x minus 7. That's what I want all the denominators to be. So this is going to need an x, and this is going to need an x minus 7. Now all the denominators are the same. And if all the denominators are the same, all the denominators cancel. So if all the denominators are the same, then the denominators are gone. That will give us x minus 85 plus 12x equals x squared minus 49. Because if you take this times this times this times this, you get x squared minus 49. Okay. Now, this didn't happen to us in our last problem, because the last problem the x squared is canceled. This time the x squared did not cancel. So we're still going to have an x squared in the problem. So we combine like terms. We have negative 85 plus 13x equals x squared minus 49. I'm going to add 85 to both sides and subtract 13x from both sides. And that's going to give me x squared minus 13x plus 85 minus 49. 15 minus 9 is 6. 36 equals 0. And then this quadratic is factorable. X minus 4, x minus 9 equals 0. Those are factors. Wrong color. Factors of 36 that add to negative 13 are negative 4 and negative 9. So my answers are x equals 4, x equals 9. Okay, let's try another. Alright, first thing I'm going to do is rewrite the problem. I'm going to say that x minus 3, and the factored form of this would be x minus 8, x plus 3 equals 7 over x minus 8 plus 1 over 1. And I'm going to say that x cannot equal negative 3 or 8. And then I'm going to say I need common denominators. And the common denominators are x minus 8, x plus 3. And so here I should go x minus 8, x plus 3. But really, that is x squared minus 5x minus 24. So it's just easier to look at in that form. So if I attach those things to the denominators, the numerators have to have the same attachments. So this needs an x plus 3. This needs an x squared minus 5x minus 24. And we're just going to erase that 1 because it looks obnoxious. So now that the denominators are all alike, the denominators are not there. We multiply by the denominators, they would go away. That would give us x minus 3 equals 7x plus 21 plus x squared minus 5x minus 24. Combine like terms. X minus 3 equals x squared, 7x minus 5x is 2x, and 21 minus 24 is negative 3. Then move the x and the 3. And you get x squared plus x equals 0. Then you pull out the greatest common factor. And then you solve. And so the answers are negative 1 and 0. All right, last one. We're going to rewrite this in factored form, so that's 12x. This is x plus 2, x plus 1, 9, x plus 2, minus 3, x plus 1. I would write that. So the common denominator is x plus 2, x plus 1. Oh, by the way, x cannot be negative 1 or negative 2. Probably to be consistent, I should have written those the other direction. Negative 2 or negative 1, doesn't matter. Okay, so our common denominator is x plus 2, x plus 1. So this needs an x plus 1. What you do to the bottom, you have to do to the top. This needs an x plus 2. What you do to the bottom, you have to do to the top. And now that the denominators are all identical, the denominators are all gone. And that gives you 12x equals, make sure you distribute, 9x plus 9. And make sure you distribute negative 3x minus 6. Combine like terms. And there you are, my friends. So all the individual skills you knew how to do already. And so you just put them all together. All right, that's it. If you have any questions, send me an email or ask in class. Have a great day.